Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. You are welcome once again to class, and I am so excited to have you as part of my YouTube community. Today is the day 8 out of the 11-day maths challenge, and we will be exploring the question number 8 of the 2023 Neco maths exam. I'm here to help you every step of the way, and I look forward to seeing you learn and grow as we tackle this challenge together. So let's get started. As you can see, the first question there in the Neco maths question says we should evaluate without using tables. And what are we to evaluate? 5 log of what? Log of 2 plus log of 40, then minus log of 12.8. Now mind you, when a log is written like this without anything, it simply means that they want you to express it in base 10. Or when a log is written like this, it is simply the log in base 10. So let's continue with the solution. So we have to simplify everything that we have here, and simplifying this, it will now look like something like this. You know, from this rule, if you have log of a to the power of x, you know, when a log is carrying a power, you take the power to multiply the log, because it will now become what? X log e, right? Now, that is exactly how this particular part is, right? So I want to return this 5 back to become power of these 2. So this is what I mean. That is, this x goes back to become the power of a. So you're doing that with this particular one now. Here's what we are going to have. It's going to look like this: log of 2 to the power of 5. Then this is what? Plus log 40. Then minus log 12.8 can be written as this: log 128 divided by 10. Good. So 2 to the power of 5 is 32. So I'll write log of 32, then plus log of 40, then minus, right, log of what? 128 over 10. Mind you, I said that the bases are what? Are base 10, base 10, base 10. So since all the bases are the same, I'll write out just one of the bases in base 10. Then I will use the law of logarithm that says addition. When you have 2 log, let us say log a plus log b, as long as the bases are the same, right, it becomes what? Log a times log b. So we are using that same rule here. So this will now become 32, right? This is plus, so it becomes multiplication, right, times 40. Then mind you, minus is division, right? So, and when division turns to multiplication, what is down will go up, what is up will come down. So this will now become times 10 everything over 128, right? Good. So let's simplify now. 4 can go here 10, 4 can go here 32 times, then 32 here 1, 32 here 1. So at the end we have what? We have this to be what? Log in base 10. Then we have 10 times 10 is 100, right? But I'll put it like this: 10 to the power of 2. And when the log is carrying a power, the power multiplies the log. So the result here becomes 2 log of 10 base of 10. And when the log is carrying the same base as the number, right, it becomes 1. So the base here cancels this base here, so this becomes 2. So that is the result of the first question in number 8. So this is the A part. Is that fine? So let's look at the B question. Alright, the B question says that find the equation of a curve which passes through the points -2 and 5 and has a gradient of 6x squared plus 8x minus 3 at any point on the curve. So this is the question we want to tackle, and it has a gradient of 6x squared plus 8x minus 3 at any point on the curve. So, and in mathematics, when anything is a gradient, that thing is the same as saying dy dx, right? Good. So we are going to use that same approach to tackle this particular problem. We were given that dy dx is 6x squared plus 8x minus 3. Good. So if I multiply both sides by dx, right? So dx here, we cancel dx. I will now have dy to become 6x squared plus 8x minus 3, right? Good. So I'll multiply this with the x. So this is what I will have if dx multiplies this. So in order to obtain y, I have to integrate both sides. Integrating both sides, I will have the integral of dy to be equals to the integral of everything I have in the bracket, which is 6x squared plus 8x minus 3 dx. Now in integration, what we do in integration is this: assuming you are given this function y equals to x to the power of n and you want to integrate y, what you do is this, right? In integration, you add 1 to the power, then you divide by the sum of the power. So the sum of the power here is n plus 1. So this is all we do in integration, right? So I will put this in a small box here so that we can reference it while we are doing this. So going with this, if you differentiate dy, you will obtain y. So to differentiate 6x squared, you write 6, you write the x, and you put the square, then you add a 1 to it. Then the sum of the power, 2 plus 1, this 2 plus this 1 gives you 3. Then plus, then in this other part too, you have it as what? 8x, the power is 1, then you add another 1 to it based on this formula. Then 1 plus 1 gives you what? 2. Then minus 3. The power of x here is 0. So we are going to put 0, then we are going to add 1 to it, and 0 plus 1 gives us 1. So let's scroll up, right? So if you simplify this, this becomes what? 6x, then 2 plus 1 is 3, then divided by 3, plus this is what, 8x, 1 plus 1 is 2, then divide by 2, then minus 0 plus 1 is 1, so this is 3x over 1, so 3 here 1, 3 here 2, 2 here 1, 2 here 4, so our y now becomes what, 2x to the power of 3 plus 4x to the power of 2 minus 3x. Now go back to the question and you will see we were given some points. So let's look at those points that we were given, because we were told that that particular gradient passes through 2 points. Let's look at those 2 points. We're told that it passes through the point minus 2 and passes through this point minus 2 and 5. So, and in coordinate, the first is usually x and the second is y. So we are going to substitute those two values in the equation that we just derived. Now let me state it clear that once you integrate, it's necessary you add a constant c to your integration at all times. Good. So we have found out that the values for x, we are going to put x to be minus 2 and y to be 5. So putting y to be 5 here, this becomes 5 equals to 2 into bracket negative 2 cube plus 4, then negative 2 square minus 3 times negative 2, then plus constant c. So this gives us 5 equals to 2. Negative 2 to the power of 3 will give us negative 8, then plus 4. Negative 2 to the power of 2 will give us 4. Then negative 3 times negative 2 will give us plus 6. Then we have plus c. So let's simplify further. This is 5. 2 times minus 8 is minus 16. Then 4 times 4 is 16. Then we have plus 6. Then plus c. Now 16 minus 16 plus 16 will cancel out because it gives us 0. Therefore c, if 6 crosses to this other side, the positive here will turn to negative. So this becomes 5 minus 6. And 5 minus 6 is negative 1. Hence, we can say the required equation is, now you go back to this other part, you go back to this point where you have this equation, then you add the value of c, which is minus 1. Right? That is all you'll be doing there. And that required equation is, so this is the result to that particular question. Then let's look at question C. We are asked to differentiate 3x squared plus 4x minus 5 with respect to x. So let's do that. We were given that y is 3x squared plus 4x minus 5. So we want to differentiate this, and in differentiation, this is what we do in differentiation. If you want to differentiate y is equals to x to the power of n, for instance, when you say dy over dx, what you do is that you take this power, you multiply what you have here, which is x to the power of n, then you subtract 1. That is why we say differentiation and integration, they are reversed process. Now, using that method now, therefore, we can say that dy over dx would now become 2 times 3 x to the power of 2 which is this 2, then you subtract 1. Let me use this bracket. Good. Then plus the power here is 1. This become 1 times 4x. The power here is what? 1, because x to the power 1 is still x. Then minus 1. Then minus. Good. Let me clean what I have here. Here, x that is here is actually x to the power of 0, because anything to the power of 0 gives us 1, and 1 times 5 is 5. That is why they did not bother to put x to the power of 0. So when you differentiate a constant, this is what you will obtain. So this becomes 0 multiplied by 5x to the power of 0 minus 1. So for the fact that this will multiply by 0, everything here renders to become 0. Good. So you have this to be 2 times 3x, because 2 minus 1 is 1, then plus 1 times 4x. 1 minus 1 is 0, then this is minus 0. Therefore you can say that dy dx is 2 times 3x, which is what? 6x. Then anything to the power of 0 is 1. 1 times 4 is 4, and 4 times 1 is 4. So this is the value for dy ds. So this brings us to the end of today's math challenge. Kindly subscribe to this channel if you are yet to do so, and share this video with your friends and loved ones. Bye for now.